Assalamualaikum. My name is Nurus Nazwa binti Muhammad Nurisa and my number matric is 70 DKA23F1027 and I will present about our mini project steel design. So for the introduction, the purpose of this project is to design a single-story steel structure building that meets structural safety, functionality, and economic requirements. Steel is a widely used construction material due to its high strength to weight ratio, durability, and ease of fabrication and assembly. In this project, a comprehensive analysis and design process is undertaken to ensure the building can safely support applied load, complying with relevant code and standards such as the American Institute of Steel Construction (AISC) or EuroCode, depending on the regional context. This building is envisioned for light industrial, commercial, or storage use, featuring a clear span layout to maximize usable interior space. Key design considerations include load calculation, depth, life-wide seismic, selection of appropriate structural systems such as moment frames or brace frames, material specification and connection detailing. Advanced design software and manual calculation are used in tandem to verify the integrity of the structure. The final deliverable includes structural layout drawing, member sizing, connection details, and a summary of structural analysis. The design emphasizes safety, efficiency, cost effectiveness, and ease of construction, reflecting modern engineering practice. So now I will present about beam design. For introduction for beam design, the steel structure for this single-story building is designed using universal beam UB size 610 times 305 times 179 UB and made from grade S275 steel. All beams in this design are fully laterally restrained and are classified as simply supported beam. The beams are divided into 4 groups based on different span length. The first group includes beam A12, A23, B12, B23, C12, C23, D12, and D23, each with a span of 5.5 meters. The second group consists of beam 1AB, 2AB, and 3AB, which each have a span of 4 meters. The third group include beam 1BC, 2BC, and 3BC with span of 3 meters. Lastly, the fourth group comprises beam 1CD, 2CD, and 3CD, each with a span of 4.5 meters. Next, these are the beam sketch prepared by our group. As shown, each sketch includes a 3D, a side view, and a top view. So now I will continue to the summary for beam design. The beam design project has effectively demonstrated the application of structural engineering principles in a practice context. Through comprehensive analysis and precise calculation, each beam was systematically designed to safely sustain the applied load. The design team selected a universal beam UB which dimension 610 times 305 times 179, fabricated from S275 grade structural steel. The web and flank of the selected section are classified as class 1, indicating that the beam possesses sufficient capacity to resist bending moment without experiencing premature bending or lateral instability. Both the design shear force (VED) and design bending moment (MED) were found to be lower than their respective resistance capacities, PLRD and MCRD, confirming the adequacy of the section under the given load condition. Furthermore, the beam is fully laterally restrained, thereby eliminating the risk of lateral torsional buckling. As the characteristic imposed load QK is zero, the beam is not subjected to any measurable deflection. In conclusion, the selected section satisfies the relevant structural design criteria and is the structurally sound for its indented application.
Assalamualaikum, my name is Nur Ain Natasha. My metric number is 17DKA23F1021. I will explain about column design. For introduction, the design of single-story building construct using steel column involve considering both axial load and bending moment transfer from simply supported beam. Each column in the structure has a consistent height of 5.5 meter and is specified as a 152 times 152 times 37 universe column UC section made from S275 grade steel. Due to variation in the loads acting on them, the columns are grouped into 8 different categories. Column A1 and A3 explain individual load of 4.76 kN and 6.55 kN respectively. Column A2 is subjected to a combination of 3 loads, 2 of 6.55 kN and 1 of 4.76 kN. For column B1 and B3, each carry 3 distinct loads, 4.76 kN, 3.57 kN and 6.55 kN. Column B2, on the other hand, support 4 loads in total, 4.76 kN, 3.57 kN and 2 instead of 6.55 kN. Moving on to column C1 and C3, both receive 3 loads, which is 3.57 kN, 6.56 kN and 6.55 kN. Column C2, on the other hand, support 4 loads in total, which is 3.57 kN, 6.56 kN and 2 instead of 6.55 kN. Lastly, column D1 and D3 is loaded with 6.56 kN and 6.55 kN. Whereas column D2 carry 3 loads, which is 6.56 kN and 2 loads of 6.55 kN. Each column must be designed accordingly to safely support the loads based on its group classification. Next, this is a drawing of column A1, A2 and A3. We have 4 views, which is right view, top view, 3D view and front view. Next is drawing column B1, B2 and B3. We have 3 views, which is side view, top view and 3D view. Next is drawing C1, C2, C3. We have 3 views also, which is side view, top view and 3D view. And lastly, for column D1, D2, D3, we have 4 views, which is right view, top view, 3D view and front view. As for summary for column design. In summary, the column design undertaken in this project follow fundamental structure engineer principle and mirror the approach used in beam design with a focus on real-world application. Each column has been truly analyzed and designed to safely resist the anticipated axial load and bending moment resulting from beam or other structure action, ensuring the integrity and stability of the structure. The selected section for all columns is 152 times 152 times 37 universal column UC made of S275 grade structured steel. The cross-sectional profile comprising the web and flash is classified as class 1, indicating its ability to resist bending effectively without experiencing perimeter yielding or lateral torsional buckling since all columns are uniform in height and section size. The value of Nmin BRD and YBRD remain consistent across all column groups. Following the design verification process, all column groups yield result with utilization ratio of less than 1, demonstrating that the structure capacity of each column meets the required safety criteria. Therefore, it is concluded that the chosen column section is structurally adequate and appropriate for use in the proposed single-story building.
Hi, Assalamualaikum. My name is Novazana binti Kamal Zaman. My metric number is 17DKA23F1015. So, I will continue present about roof flat design. So, for introduction, the roof structure of this single-story building incorporates trusses made from equal angle section measuring 125 times 75 times 10L, fabricated using structural steel grade S 275. These trusses span a length of 11 meters and are installed at a roof pitch of 35 degrees, with the connection configuration as illustrated in the profile diagram. External loads are applied at specific joints where a load of 17.5 kN is applied at joints A and B, while joints D, F and H each carry a load of 35 kN. This applied force generates external axial force within the truss members, which are classified as either tension or compression force. Compression force are present in member AD, DF, FH, BH, DE and EH, while members such as AC, CE, EG, BG and EF are related to tension. Specifically, members AD and BH each carry a compressive force of 153.51 kN. DF and FH carry 169.12 kN, while DE and EH resist 61.4 kN. As for the tension members, AC, CE, EG, BG and EF express a force of 125.88 kN, except for EG, which carries a lower force of 61.4 kN. The structural performance of members AD, AC, DF and EF must be assessed through appropriate design checks to ensure compliance with the required standards and design criteria. So next, in this diagram, we can see a roof truss arrangement consisting of several key components such as the bottom chord, diagonal members and vertical members. This structure is designed to efficiently distribute loads from the top down to the supports. Each section at the base of the truss measures 5.5 meters, giving a total span of 11 meters. The truss is divided into two equal horizontal sections. The downward loads applied at each main joint are 35 kN, while the outermost points to the left and right carry 17.5 kN. This shows that the loads are symmetrically distributed across the structure. This truss is designed to withstand vertical loads and maintain lateral stability of the roof structure. The triangular shapes in the truss help prevent deformation and efficiently channels load to the supports. So next, summary for roof truss design. Overall, roof trusses are structural frameworks designed to support and distribute the weight of the roof evenly throughout the building. They are carefully engineered to ensure that all applied roof loads are safely transferred to the supporting structure, maintaining the stability and safety of the entire system. Throughout the design and analysis of truss members AD, AC, DF and EF, the calculations revealed that some members meet the required strength criteria, while others do not satisfy the design limits and are therefore inadequate to carry the applied load. For members under compression, the NED value must be lower than the NTRD to ensure the member can safely resist the compressive force. Meanwhile, for tension members, the NED must be less than the NBRD. The main difference between the two cases is that compression checks include buckling resistance, whereas tension checks involve bolt arrangement and sizing. The analysis confirmed that members AD, DF and EF are safe, as their NED values are within the allowable range. However, member AC was found to exceed the NTRD value, indicating that it does not meet the design requirement and could eventually to inflate the underrated. So next, connection design welded. For introduction, for a single-story building, the connections between beams and columns are designed using welded joints. all the beams connected to the columns have the same cross-sectional size, although their length vary. These variations in length causes the design shear force VED to differ for each beam. In this welded connection design, different weld sizes are used to determine the most suitable size according to the respective VED values. For example, the connection between beam 1AB and column A1 as well as beam A12 to column A1 use a 3 mm weld size. Meanwhile, the connections from beam 1AB, 1BC and B12 to column B1 use a 5 mm weld size. At column C1, the connections from beam 1BC, 1CD and C12 use a 4 mm weld size. Lastly, the connection from beam 1CD and D12 to column D1 use a 6 mm weld size. The welded areas also vary. The connections are fully welded around the entire joint, while others may only welded radially, such as along the web of the beam. Therefore, it is necessary to evaluate the adequacy of each welded connection to ensure structural safety and performance. So lastly, summary for connection design welded. The use welded connections is a reliable and widely accepted method for joining structural elements guided by fundamental engineering principles. In these single-story building projects, welded joints were selected over bolted connections due to relatively simpler calculation process and more straightforward implementation. Throughout the design process, it was observed that both the size of the weld and the welded area significantly influence the design shear resistance FRED, even when the design shear force VED remains constant. While increasing the weld size and area enhance the load bearing capacity of the connection, it also results in higher construction costs. Therefore, selecting a weld size that offers an optimal balance between structural performance and cost effectiveness is a step. Based on the result of our calculations, a weld size of 3 mm was found to be adequate for all beam to column connections within the structure. This weld size provides a design resistance FWRD that assists the applied design force FRED, ensuring that the connections are structurally safe and capable of withstanding the aspect loads. In conclusion, the welded connection design for this single-story structure can be safely executed using a 3 mm weld size for all joints, meeting both strict and economic considerations.
Last is conclusion. This project centers on designing a single-story steel structure by addressing critical components such as beam, column, roof truss, and their connection. EuroCAD 3 serves as the primary guideline throughout the analysis and design process to verify that each element meets the necessary requirement for strength, stability, and safety. Through this exercise, a comprehensive understanding was gained on how individual structure members interact as a part of cohesive system, while also enhance practical skill and apply theoretical engineering knowledge to real-life steel construction.